Equation of a straight line y is equal to mx plus c is what we're looking at in this video. So the video is split into 4 parts. In part 1, we're looking at examples like this. How do you identify the gradient and the y-intercept from something like this? In part 2, we're looking at examples like this with 1 quadrant graphs. Then we're looking at examples like this with 4 quadrant graphs. And then finally, we're looking at examples like this on identifying graphs. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and have a go at the example on the right, which is you do. So here we've been asked to find the gradient and the y-intercept of this. Now the equation of a line can be written as y, just make that a little bit thinner, can be written as y is equal to mx plus c. Okay, that's the equation of a straight line, where m is what we call the gradient. Okay, so this question's asking for the gradient. So if you look at this, the gradient is the term next to the x. So the term next to the x here is 3. So we know that in this question, the gradient, which we normally call m, can be given as 3. Okay, so that's the gradient. And the y-intercept is this plus c here. So that's where it crosses the y-axis. So this remaining part here is what we call the y-intercept. So the y-intercept here is going to be 2. Okay, so hopefully you've pressed pause and had a go at the example on the right. Now remember, the term next to the x is what's the gradient. So the gradient here is 5. And the remaining term there is the 4, which is the y-intercept. So looking at this one here, again, the exact same principle applies. So y is equal to mx plus c is the equation of a straight line. The term next to the x is the gradient, and the remaining term is the y-intercept. So again, hopefully you've pressed pause and had a go at this. So the gradient here, there's actually an invisible 1 there. So the gradient here is 1x, so that's just going to be 1, and the y-intercept is 4. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. Moving on. So we're looking at some slightly trickier examples here, but the exact same principle applies. So we have y is equal to mx plus c, and the gradient is m. So that's the term next to the x, and the remaining term is -1 this time. Okay, so the y-intercept this time is -1. And again, hopefully you've pressed pause and had a go at this. So the gradient is that, and your y-intercept would be -5. So moving on from there, now with this one, the term next to the x is a -1. Okay, so the gradient is -1, and the y-intercept is -10. And again, hopefully you've pressed pause and had a go at this. So the gradient here is -14, and the y-intercept is -3. So looking at this one here, now if I write down the equation of a straight line, y is equal to mx plus c, you'll notice there's no x term. Okay, that means the gradient of this line is 0. Okay, so we do have a y-intercept, which is 3. So the line crosses the y-axis at 3, but it does not have a gradient. And again, the same thing here, y is equal to mx plus c, there's no x term, so the gradient is 0, and the y-intercept is 5. So looking at this one, again, y is equal to mx plus c, the term next to the x is the gradient. So the gradient here is 6, but there is no c, so there's no y-intercept. That means it crosses through 0. Okay, and again, hopefully you've pressed pause and had a go here. So the y-intercept is 0, and the gradient is 1, because there's a 1 on here. Okay, so looking at this one, now the equation of a straight line is given in this form. Y is equal to mx plus c. Now what you'd notice here is, it's not y is equal to, it's y plus 4x is equal to. So what we need to do is we need to move this over that way. Okay, and the way we do that is we do the opposite of plus 4x. So if you subtract 4x from each side, that cancels out and you're left with y is equal to minus 4x plus 3. And now that's written in the same form. And now we can say the gradient is -4 and the y-intercept is 3. Okay, so it has to be written in the form y is equal to mx plus c. So again, with this one here, so we can move over the 6x, so it's a positive 6x here. So we subtract 6x from each side, I will get -y is equal to -6x -9. And now all I need to do is get rid of this negative sign, because it's y is equal to mx plus c. Okay, we just want y on its own. So if I multiply each side by -1, I get y, so that negative sign cancels out here with the -1, and we get 6x plus 9. So I can say the gradient of this line is 6 and the y-intercept is 9. Now this one was a bit trickier because we did have negative numbers there. We ended up with a negative sign. So looking at this one here, now you might be tempted to say, well, actually the gradient is 8. And that's not quite right, okay? The reason for that is because the equation of the line is y is equal to mx plus c, okay? And at the minute, we have that 2 there. So to get rid of that 2, we can divide each side by 2. That would cancel that 2 out. We get y is equal to 8 divided by 2 and 12 divided by 2. So now, gradient is 4 and the y-intercept is 6, okay? So hopefully you've pressed pause here and had a go. So again, we just want to get rid of the 3 on the y. So divide each side by 3, we get y is equal to 3x minus 2. Your gradient is 3, your y-intercept is negative 2. Moving on, again, the exact same principle applies. We've just got to put it in the form y is equal to mx plus c. So in this case, we are going to move that over there. So 2y is equal to minus 5x minus 8. And if I divide each side by 2, I get y is equal to minus 5 over 2x minus 4. So my gradient is going to be minus 5 over 2, and my y-intercept is going to be minus 4. Okay? So again, with this one, start off by moving that over. So minus 4y is equal to minus 16x minus 20. Divide each side by 4. You get minus y is equal to minus 4x minus 5, and times each side by minus 1 to get rid of the negative sign, and that gives you 4x plus 5. And your gradient is going to be 4, and your y-intercept is going to be 5. So, here's some practice questions. You need to press pause now and have a go. And I'm going to put the answers up now. Here are the answers, mark your work. So, looking at this example here, we've been asked to find the y-intercept. We've got a one quadrant graph here. So the y-intercept, so this is the y-axis and this is the x-axis. The y-intercept is just where the green line crosses the graph. So the green line crosses the graph right there. So the y-intercept is 2. Okay, now hopefully you've pressed pause and had a go at the example on the right. So the answer here would be 6. The graph crosses the y-axis at 9. So we are just looking for the y-intercept here, okay? So the correct answer is 9. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. So looking at this one, we've been asked to find the equation of the line, okay? So if you go back to where we started, that was with y is equal to mx plus c, okay? Now, we know how to find c. C is just the y-intercept, so it's where the graph crosses the y-axis, so we can do that. That's plus 2 done. So the only thing we need to now find is m, okay? M is the gradient. Now to find the gradient, we pick 2 nice points on the graph, so on the line. So we look at the green line, and what I mean by a nice point is this would be a nice point because it's easy to read off both sides, okay? What wouldn't be a nice point would be something like this, because you can't quite read that off down here, okay? So the nice points on this line would be that one, that one, that one, and that one. Now you pick any 2 and you draw a triangle, so you could draw a triangle like this, or like this, or you could pick these 2. So I'm going to go with that point there, and that point there, and I'm going to draw my triangle. And that is my triangle. That line really should be coming a bit this way. There we go. And I can see my triangle goes 2 across, and it goes 3 up. And now we're not counting the squares, just to be clear here. We're counting from 5 to 2. So that 5 minus 2 is 3. And on this side, the width of it, we're going from 0 to 2. Okay? So the gradient is going to be the change in y divided by the change in x. So what that means is it's the height of the triangle divided by the width. So that's my gradient there. Done. So my final answer is y is equal to 3 over 2x plus 2. So hopefully you've pressed pause and had a go at the example on the right. So we have y is equal to mx plus c. Now you can start off with the easy part, which is the y-intercept. So that's just plus 5. That's done. Now all you need to do is find m. M is the gradient. So to find the gradient, we pick 2 nice points. So I would pick that one there, and what else is a nice point? Let's have a look at that one there. Okay. So then I draw my triangle. And then on the base, it goes from 0 to 5. And on the height, it goes from 5 to 7. So now I just do 2 over 5, and that's my gradient. So, looking at this one here, So what's different with this one is the line is pointing down, so we're going to end up with a negative gradient. Okay, so the exact same approach applies. Y is equal to mx plus c. I'll do the easy part first, so I can see it crosses the y-axis at 9, so that's the intercept done. Now to find the gradient m, I'll just pick two nice points on this line. So the two nice points you can pick from would be any two of these, okay? You can pick these two as well if you like. So I'm going to go, this time, I'm going to go with these two. So that goes across there, and that goes down. Let me just draw that a little bit clearer. There we go. So that is 1 across, from 1 to 2, and it goes from 3 to 6, which is 3 that way. So we write the y over the x. So remember, the gradient is the change in y divided by change in x. So it's going to be 3 over 1, which just becomes 3. But because the line is pointing down, the gradient is negative, so we stick a negative sign on that. So that is the final answer there. Okay? So again, hopefully you've pressed pause and had a go at this example here. Y is equal to mx plus c. The intercept is 10. If I pick two nice points, so I can pick that one there and that one there. And if I draw my triangle, I can see that goes across by 5 and it goes up by 3. So that's going to be 3 over 5x, and it's going to be negative because it's got a negative gradient on the graph. So here's some practice questions. You need to press pause now and have a go. I'm about to put the answers up just now. Here are the answers. Mark your work. So moving on from there. So we're now looking at 4 quadrant graphs. Okay. So these are graphs that have 4 quadrants. It's got 1, 2, 3, 4 quadrants. But the exact same approach applies, right? Y is equal to mx plus c. C is the y-intercept. So where does the graph cross the y-axis? That's the y-axis. It crosses right there at that point there, which is 6. So that's done. So the only thing we need to find now is the gradient. And the same approach, pick two nice points. So the two nice points on this line would be any of these two. Okay, so I'm going to go with, I try to stick in the positive quadrant. Makes life a little bit easier, so I'm going to go with that one. So I can see if we go 2 across that way. And now notice, this is where people get it wrong. It's 2 up. The reason it's 2 up is because we're not counting the square. They're going from here to here, right? That goes from 8 to 6. So each square going up is 2. And you can see that down here. Each square going up is 2. Each square going across is 1. Okay? So that's 2 by 2. So 2 divided by 2 is just 1. So my final answer is y is equal to x plus 6. So again, hopefully you've pressed pause and had a go at this example on the right. Y is equal to mx plus c. The gradient, the intercept, sorry, is plus 4. I can see that. But the gradient, again, just two nice points. I'll go with that one and that one. So that is 2 that way, and that would be 6 that way. That is going to be 3x. So 6 over 2, which is 3, and that is your answer there. So looking at this one here, where the lines are slightly, the scale is slightly different, sorry, on the axis. And just to mention as well, I have linked these worksheets down in the comments below if you do want to print them off and go through them. The slides and the worksheet. So y is equal to mx plus c. The y-intercept, negative 8. The gradient from there, so that goes across by 2, and you can see that starts at 0 and it goes till 2. And going up, it goes from minus 8 to 2, so it's just going to go up by 2. So that's just going to be 1. So y is equal to 1x minus 8. And again, hopefully press pause and I had a go at the example on the right. So this one, the y-intercept I can see is right there, negative 10. Let's put that in. So it'll be something x, negative 10. And the gradient, so pick two nice points. So I'm going to go with that one there and that one there. So going across, that's 0.5, and going up, that's 8. So that's just going to be 16x minus 10, because 8 divided by 0.5 is 16. So moving on. So here's another question. So we have y is equal to mx plus c. The y-intercept is 3. And the gradient, just two nice points. So if I pick them two, I can see I'm going 2 across and 2 up. So that'll just be 1x plus 3. And again, hopefully you've pressed pause and had a go at this example on the right. So the y-intercept is negative 3. The gradient is just going to be that point there and there. So if I go 4 across, 1 up, that would be 1 over 4x minus 3. So here's some practice questions. There's 2 parts to this, so press pause now and have a go. I'm about to put the answers up now. Here are the answers. Mark your work. And we've got some more practice questions on this one. So again, press pause now and have a go. I'm about to put the answers up now. So here are the answers. Mark your work. So looking at this one here, so this time we have a negative gradient because I can see that line is coming down. So again, the exact same approach applies. Y is equal to mx plus c, where c is your y-intercept, so that's positive 8. Your gradient is just going to be a case of picking 2 nice points, so we can pick them 2, so that is going 1 across, 2 down, so that is going to be 2 divided by 1, which is 2. So in this case, because the gradient's negative, that's going to be y is equal to negative 2x plus 8. And for this one here, we have y is equal to, it crosses at 6. If I pick 2 nice points, that would be that one and that one. Draw my triangle, that is 2 across, 6 this way, that is going to be negative 3x. Because 6 divided by 2 is 3, and because the gradient's negative, you stick a negative sign on it. So just as a little tip, if you're not too sure how to tell if a line's got a negative gradient, so you can just do something like this. When you see a line, just draw something like this on the sides of it, and you can see with this one, it ends up looking like an N. So that means this has a negative gradient, whereas this one looks like a backwards N, okay? So with this one, the gradient is positive, okay? Because that doesn't look like an N, does it? Whereas with this one, that looks like an N there. So that is negative. That's how you can remember it, if that helps. And as soon as you see the line's got a negative gradient, you just stick a negative on the M term, okay? So now I recommend you press pause and you have a go at this. So you're just matching up which letter goes with which graph, okay? And I'll go through it. So I'm going to go through it now. So with this one here, the most obvious one to me here is that one there. It's a flat line. It's got no gradient. Because it's got no gradient, there's no x term. So that's going to be that one there, okay? There's no x term. The gradient is 0. And the next one that stands out to me at the other two is the fact that one's got a positive gradient and one's got a negative gradient. Now I can see that because if I do that little trick we did earlier, that's N. That means it's got a negative x term, okay? So that's going to be that one there, and that means this one is going to be that one there. So again, press pause and have a go. So looking at this, the most obvious one that stands out to me out of these is that one there. It's the only one with a negative gradient, and I can see that is the only x term with a negative, so that is going to be C. And with the other two, they've both got a positive gradient, whereas this one is much steeper than that one. And because it's steeper, that means the x term is going to be higher. So that's B, and that is A. And finally with this one, again, the one that stands out to me is this one here. It's got a negative gradient, so straight away, that's the only one here with a negative gradient. And with the other two, the gradient's the same, so they both are as steep as each other. However, the y-intercepts are different. So this one crosses through -1, so I can see that's going to be there, and that's passing through 5. So that's going to be B, and that's going to be A. So looking at this question here, we've been given a graph of the distance travelled by a train and the time it took in hours, and they want us to obtain a formula for D in terms of T. Now remember, the equation of a straight line is given as y is equal to mx plus c. Now if I look at the y-axis, it's given as D. So let's change that to D. D is equal to, and if I look at the x-axis, we have a T. Let's change the x to a T. And the y-intercept, obviously we can just read that straight off, that's just 90. So the only thing we're left to find is the gradient. So to find the gradient, we pick 2 nice points, like that one there and that one there. We go 1 across, and we go up by 45 each time. So 45 times 3 would be 135. So that is my formula there. Okay, so again, hopefully you've pressed pause and had a go at this example here. So y is equal to mx plus c. I can see that the y-intercept is denoted as c. I can see the x-axis is denoted as n. I can see it crosses the y-intercept at 10, so that's your y-intercept. So the only thing we've got left to find is the gradient now. So to find the gradient, we just pick a nice point like that one there. Go across, go up, so that's 100 across, and that is going to be 5 up. So that is just going to be 5 over 100. Now we can simplify that, or we can just leave it like that, but that is our answer there. So here's some practice questions. press pause now and have a go. Okay, I'm about to put the answers up just now. So here are the answers. Mark your work. And if you would like some more practice on this, I have got a full worksheet on this link down in the comments below over on my website. And if you found this video useful, I've got loads of other content like this on my YouTube channel. Do check it out.